Today we're going to be talking about dividing radicals. Now, when it comes to dividing radicals, it's actually pretty simple. So if we take this example here, 12 square root of 160, and let me get that into focus here. There we go. 2 radical 5. So the numbers on the outside will divide like you normally expect. So, that's going to give us 6 on top. Now, the rest of it, though, now that is actually a lot simpler as well. So, believe it or not, when you have 2 radicals, one divided by the other, we can actually rewrite them as one large radical, where we divide the numbers on the inside, and we just take the square root of both. Now, this is very useful to us. The reason why we can do this is simply because this is the same radical on top and bottom. If they were different radicals, this trick would not work. Now, if we do this, we get 6 times the square root of 32. And then this breaks down in something we can actually deal with. 16 and 2. 16 breaks down to 4 and 4. Pair of 4s. Bring a pair of 4s out. Radical 2 stays under. So you get 6 times 4, which is 24, radical 2. And there we go. So we'll look at a few other ones real quick. Like if we have 36 in the 4th root of 1250 over 9 times the 4th root of 2. Well, 36 divided by 9, straightforward. That's 19, 4. Then what we can do, take this, rewrite it as 1. 1250 divided by 2. 1250 divided by 2 is 625. And if you actually type the 4th root, excuse me, pardon. So we can either break this down, or we can type the 4th root of 125 or 625 in the calculator. And breaking it down, we get 4 5s. So this actually breaks down completely, giving us 4 times 5, which is 20. So final answer would be 20. The same idea works if you have variables instead. So if it was, say, square root of x cubed y9 divided by the square root of x squared y5, rewrite as x cubed y9 over x squared y5. If you don't know this already, when we divide variables, you want to subtract the exponents. So this becomes the square root of x y4. Well, with square root, we're looking for pairs, so we can't make a pair of x's, but y's we can make not 1, but 2 pairs. So this gives us y squared square root of x. There we go. So let's do one more. So if we have cube root of 7x to the 5th over 64 y to the 6th. Not only can you put things together, but you can also break them back apart as well. So I can break this up, because sometimes we actually need to. Because 7 divided by 64 doesn't divide, and x and y's can't be subtracted from each other. So this is actually one where we want to break it up and get cube root of 7x to the 5th over the cube root of 64y6. Well, x's, we got 5. We need 3. So for the top, we can pull out ax, and then we have to put 7x squared back inside because it doesn't reduce. Now, for the rest of this, though, 64, I'm so sorry. 4 goes in 64 16 times. 4 and 16 be broken down into 4 and 4. 3 4s. So we'll pull, it's still on the bottom here, so you have to put your division bar. So you put a 4 there. Then you got 6 y's, so we can make 2 groups of 3. So it becomes 4y squared. And there you go. Now, this gets a little bit more complicated when the denominator doesn't actually break down completely. When that happens, we have to use a technique called rationalization here. So, now here's how that works. So if we have a problem, say 3 over 2 radical 5, then I can't break radical 5 down. So what I have to do is I have to rationalize it, which means we're going to multiply radical 5 by itself, but I have to do that to the top and the bottom. So this gives me 3 radical 5 up top, and this gives me 2 times square roots. When you multiply them together, the radicals disappear and simply become the number underneath. So this gives us 3 radical 5 over 10. Now, what happens though if we have a problem where there's a radical on the top as well? You know, what are we supposed to do? Or, moreover, what if there's a number as well down the bottom with the radical? Well, the number in the bottom, don't worry about it. Simply worry about the radical itself. So we use square root of 7. Now, if we do that, and when we multiply the radicals, you know, just like we did before, they're going to become like square root of 12 times 7. This will just become 4 times 7 in the bottom. Now, square root of 12 times 7 is 84. Oh, gosh. I don't know why I'm so tired. I'm sorry. And 4 times 7 is 28. 84 can be broken down into 4 times 10, 15, 16. 16 can be broken down into 4 and 4. Luckily, 2 can be broken down into 2 and... That's not right. 84 breaks down to 4 and 21. 21 breaks down to 3 and 7. 4 breaks down to 2 and 2. Pair of 2's, excuse me. So you pull a 2 out to multiply with 3. 3 and 7 go back together to make 21. So it gives us 6 radical 21 over 28. And because 6 and 28 are both even, you would divide them both by 2 and get 3 radical 21 over 14. And that would actually be your final answer. So, now let's take a look at one more. So, with this one, we have 2 things in the top here not connected, and we can't combine them first. If you can, you want to. So first, we're just going to start by rationalizing. Now, that's going to give us 12 in the bottom, but we're going to take the square root of 12 and multiply it against both of these. So 3 times radical 2 times radical 12 is radical 24. Plus radical 12 times radical 6. 12 times 6 is 72. So we have to break both of these down. Now 24 breaks down into 4 and 6, 2 and 3, 2 and 2. So that breaks down to 3 times 2, which is 6. Radical 6. 72 breaks down to 8 and 9. 8 is 4 and 2. 4 breaks down to 2 and 2. 9 into 3 and 3. So So you get 2 times 3 here because we had a pair of 2's and a pair of 3's. 2 times 3 is 6. Put the radical 2 back under. Then 12. Now 6, 6, and 12. 6 divides into all 3 of them. So this becomes 1 radical 6 plus 1 radical 2 over 2. That 2 would not divide into radical 6 or radical 2. Straight up, because 2 is a rational number and the 2 square roots are irrational. They are square roots. And you cannot divide an irrational number by a rational. So, it just does not work out. Now, each of these was, now those last 3, those were all cases where we were dividing by what we refer to as a monomial, meaning there was only one term in the bottom. Now, the method that we have to use if it is not a monomial is actually different if it is a binomial. And typically you only run into these where it's monomial and binomial. If you run to a trinomial, then we have to break it down even further. But let's just worry about if we get a binomial here. So if you have 4 over 4 plus radical 2. Now, you could do 4 divided by 4, but because the radical 2 is adding to this 4 and not the top one, that actually makes it impossible to divide it instead. So what we have to do here is we have to rationalize this denominator. Now, this is going to be a little different from the monomial, because we're not just going to be multiplying by the radical 2, but we have to multiply by the 4 as well, our rational number here. Not only that, but we're using what is referred to as the conjugate here. So the opposite sign. So we have to use the opposite sign of whatever a radical is. So if a radical is positive, we have to multiply by the negative version. If the radical is negative originally, we have to multiply by the positive version. Now, if we do this, 4 times 4 is 16. 4 times negative radical 2 is negative 4 radical 2. Now, when you multiply 2 binomials together and they are conjugates of one another, here's a tip. You're going to eventually, you'll do 4 times 4, and that's sensible enough. That's going to give you 16. And we'll have to do radical 2 times radical 2. Well, radical 2 times radical 2 gives me radical 4, which simplifies to 2. So I'm just going to go ahead and write this as 2 here. Just keep in mind radical 4. Radical 2 times radical 2 gave me radical 4, and radical 4 equals 2. But technically we should also be doing radical 2 times 4 and 4 times negative radical 2. Now here's the thing. With conjugates, since we're using the opposite sign of one of the numbers, what's going to happen is 2 of your middle terms is going to cancel out every single time. So, pro tip, when you multiply something by its conjugate, simply multiply the 2 fronts and the 2 backs every time, and it'll work out. Now, this can simplify. This becomes 16 minus 4 radical 2 over 14. 2 can divide into all those numbers. So this becomes 8 minus 2 radical 2 over 7. We couldn't reduce it anymore because 7 is not divisible by 2. Now we'll look at 2 more. So let's do 2 over 6 minus radical 5. So for this one, conjugate would be 6 plus radical 5, top and bottom. So 6 times 2 is 12. 2 times radical 5 is 2 radical 5. Like I said, when you multiply something by its conjugate, fronts, backs. Those are the only two that are really going to matter. 6 and 6 makes 36. If I multiply the same radical by itself, it's just going to give me what's underneath the radical, so 36 minus 5. So 12 plus 2 radical 5 is divisible by 36 minus 5, which is 31. And that's it. That's all you can do. Now, let's look at one more. So let's look at if we had 3 plus radical 7 over 2 plus 2 radical 7. So, conjugates is going to be 2 minus 2 radical 7. 2 minus 2 radical 7. Now, you may want to utilize a Punnett square to multiply these two together. In fact, it's not a bad idea. So I'm going to take my own advice here. 2 minus 2 radical 7. And 3 plus radical 7. 3 and 2 makes 6. 3 times negative 2 radical 7 is negative 6 radical 7. This makes 2 radical 7. And this gives me negative 2 times 7, which is negative 14. So, top's going to be, well, 6 minus 14 is negative 8. Negative 6 radical 7 and 2 radical 7 makes negative 4 radical 7. 2 and 2 makes 4. And this is going to make negative 2 times, or negative, sorry, negative 2 times 2 times 7. Because we have a 2 here and 2 here, and when they multiply, they're going to give us 4. So, that means we have 4 minus 2 times 2 is 4, times 7 is 28. Luckily, 4 divides into all of that, so it makes negative 2 minus radical 7. And also, 4 divides into 4 one time, or 4 minus 28 is actually negative 24. And then negative 24 divided by 4 is negative 6. So, and due to all these negatives here, we would actually turn all of these numbers positive. So because this one is negative on the bottom, that's going to change our two top numbers here to be positive as well. So anyways, so that's all there is really with dividing radicals. So really just got to be very careful with multiplying everything out. Take it slow. And that's all I got. So if you have any questions, just leave a comment or send me a message, y'all. Take care. Bye.